how your setup for your separatory funnel will be. Your separatory funnel will be hooked up to a ring stand and then in a circular ring to hold it up so you can use it. The first thing that you want to do when you get to your sep funnel is to make sure that this stopcock is in the closed position. Otherwise, when you pour in your liquid, it will go straight through and spill all over the counter. Before you turn the stopcock closed, what you need to do is tighten it. There's a nut on this side, and when you tighten that, it allows this stopcock to be a little more stiff. You have to do it so it's stiff enough to be a little tight, but also still move. So you have to kind of play with that and make sure. One of the things you need to be able to see is that there's a hole in that Teflon stopcock, and when that hole is this way and you can see it, then this is closed. So when it's closed, this knob is perpendicular to the separatory funnel. And when this is perfectly parallel to the separatory funnel, then that is open and it's ready to drain. So the first thing you want to do is tighten that nut a little bit and turn this so that it's closed. Once it's closed, you can pour your solution, your liquids into the sep funnel. You'll be doing this in a hood because some of these solvents are not good to breathe. I have to do it out of the hood so that you can hear me on the video. So now I have 2 liquids in the separatory funnel. I don't know if you're able to see, but you can see that there are 2 distinct phases. One of them looks like it's a lot bigger than the other, but I've poured in 10 mils of each. It's just the shape of the separatory funnel makes it look like that. So I'm going to show you the correct way to do this safely. What I have seen in the past is people put 2 solvents in a separatory funnel and shake it up, and it builds up so much pressure that the lid explodes, shoots off, and hits another person, and you definitely don't want that to happen. So there's a really important way to do this to keep yourself safe and to keep the people that you're around safe while you're doing it. So the first thing to do is to turn the lid of the stopcock so that it's pointing in the same direction as the little knob on the stopcock. That way you can put your fingers on top of that lid holding the separatory funnel now, and you're now holding the lid on. And that's really good because if it builds up pressure, now the lid won't shoot off and hit somebody in the eye. The very first time that you start to mix the liquids, you need to do it very gently. And you're going to allow this to build up pressure, but you're going to release the pressure so that it's safe. So the very first time you turn it over once, and you open up the stopcock, and I don't know if you could hear that on the video, but it goes psh. So then I close it back up, do that again, open it, and this time it made that same psh sound, but it's a little bit quieter. The third time, I hardly hear it at all. And so I'm turning this and pointing it into the hood, away from my face, away from my neighbor's face, and that way no harm can come from this. So I think it's ready now to go ahead and start shaking the separatory funnel. It's really important that you always mix the 2 solvents thoroughly when you do an extraction, because molecules don't have legs and they don't jump up and run to another layer. In order for them to have preference for one phase or the other, they have to be immersed in all the molecules of those different solvents, and this is the best way to do it, shaking it. As you're doing it, you'll vent every once in a while, but you can see this time when I'm venting, very little. I didn't hear that loud sound. So I've mixed these all very thoroughly, and I leave it to sit for a minute or 2 while the 2 layers separate. And when it's time to drain it into a beaker, the thing that would be really helpful is to lower this ring stand a little bit so that it goes directly into the beaker. The other thing is, if I open this to drain, it might drain really, really slowly, because right now I'm not realizing that the laws of physics and picnics apply to organic chemistry lab. So you can see how slowly this is draining while I have it open. I'm going to close it again and do something completely different. I'm going to take the lid off the stopcock, and that allows the pressure inside and the pressure outside to be the same so that it can drain. And now it's going to drain. I'm trying not to get my hand right in the way, but it's going to drain a whole lot more quickly. Okay, so what I do is let it drain until get that last little bit, and then I have it somewhat closed and do that very, very slowly and carefully. Now what I have done is separate the bottom layer from the top layer, and I'm going to show you how to use drying agents. As you know, if you've read the background material on drying agents, the drying agent is used to get rid of any water, okay, tiny drops of water that have gotten stuck in the organic solvent that your eyes can't see. If your eyes can actually see drops of water, you're going to have to use more drying agent until you can't see drops of water, because it's there to take out tiny amounts of water your eyes can't see. So take a good look at this. I can see one drop. I don't know if you're able to see it on the video or not. I can see one drop, so I'm going to have to put a little more drying agent than usual. The drying agent here is anhydrous magnesium sulfate. It's an ionic compound, and when I add it to the organic solvent, it doesn't dissolve. I'm not surprised by that, because I understand something about intermolecular forces between ionic compounds and organic solvents. But that's one thing you're going to have to convince yourself. So as you can see, I start with this powdery white solid, and I add it to the liquid, and it doesn't dissolve, but some of that powdery white solid has now spread out and stuck to the bottom of the beaker. That's because the anhydrous magnesium sulfate is reaching out and grabbing any water molecules that are present, and they are now becoming magnesium sulfate that's hydrated. And it's sticky. So when it's anhydrous, it's powdery and it floats around freely. And when it's not anhydrous, when it's magnesium sulfate with waters associated to it, it sticks to the bottom of the beaker. And so there's no magnesium sulfate floating around right now. I have to add magnesium sulfate until I know that all the water molecules have been grabbed up. So how can I know that? Well, I'm going to add a little bit more of this. Remember, it's powdery. It would float around freely if it's still anhydrous. So I'm going to add it to the beaker, and then I'm swirling it, and I'm paying attention to what happens as it swirls. If you can see tiny amounts of powder floating around, now I have magnesium sulfate that's anhydrous in this organic solvent, which means I've already gotten rid of all the water molecules. And that's what you have to pay attention to. One of the things you have to be really careful about is if you have so much water that you have a water layer floating on top or on the bottom of your solvent, because then you are going to have to add a lot of magnesium sulfate. If you add too much magnesium sulfate, it will sort of act like silica gel and grab up all of your caffeine. So you need to be really careful not to use too much. If you're confused, make sure and ask your instructor for some help. Once you've let this sit for about 5 minutes, it allows all of the water molecules to be grabbed up by the magnesium sulfate. And now you have to get the solvent with the caffeine dissolved in it away from the magnesium sulfate at the bottom of the beaker. And so you have to carefully decant the liquid from the solid. And all that means is to carefully pour away. If you use too much magnesium sulfate, you're going to have so much free floating particles that it's going to be very difficult to do this step. And so you have to be very careful not to use too much drying agent.